Hi, my name is Lukas Kosiński and I am the CEO of SciStudio, custom software and hardware development company. Welcome back to our course on creating medical devices software using Qt framework. In this episode, we will be diving into how to choose the right embedded target for your medical device. This is a critical decision. It can impact everything from performance and power consumption to development time and costs. The choice of embedded hardware is just as important as the software running on this target. Factors like processing power, real-time performance, cost, and even regulatory considerations, all of them, they play a huge role in this decision. So yeah, let's explore these factors and see how Qt support you along the way. Before we proceed, let's clarify what we mean by embedded target. An embedded target refers to the actual hardware platform that will run the software of your medical device. This can range from simple microcontrollers to more powerful microprocessors. Your choice of hardware will dictate what kind of software you can deploy, including which features, interfaces, and user experiences are feasible. Medical devices can actually also run on regular PCs, so it's tough to say what embedded device actually mean. The best explanation that I have heard so far is that embedded means closed. So embedded devices are systems that you cannot really interfere with. You have to know what is what in terms of hardware. The boundaries when it comes to individual terms are increasingly blurred. Let's give it a try anyway. So the first term is microcontrollers, MCU. MCUs are usually equipped with necessary components like simple CPU and flash memory, but they often have a set of additional peripherals added. Microcontrollers are more power efficient and they are usually created to perform a specific task. The example of MCU is STM32 family. Microprocessors, MPUs, are on the other hand more powerful devices. They often require external memory and peripherals, and they excel at handling complex tasks such as managing multiple processes or running a rich GUI, and usually they are assembled into a system on module device, so together with memory and other necessary components. SOMs are inserted into carrier boards that come with ports and interfaces. Here you can see a system on module and carrier board from one of our partners, and here you can see an example of MPU, which is in this case an NXP IMX8 microprocessor. There are several key factors to consider when choosing an embedded target for a medical device. Medical devices come in all shapes and sizes, so do their processing requirements. A wearable heart monitor might need an MCU to handle simple tasks, while a complex surgery device could need an MPU to manage advanced computations and nice graphics. The processing power you need will directly influence your choice of embedded target. MPUs typically offer more processing capabilities, but at the cost of increased power consumption and potentially higher cost of actual device. Real-time performance is essential for many medical applications. For instance, devices that monitor vital signs need to react instantly to changes. In such cases, you might prefer an embedded target with a real-time operating system or even a bare metal MCU programming. If your device requires guaranteed response times, you should lean towards an MCU or MPU that supports real-time operations. So that's another factor to consider. The next one is power consumption. This is a crucial factor, especially for portable or wearable medical devices. MCUs generally consume less power than MPUs, making them ideal for battery-powered devices. On the other hand, if your device has access to a steady power source and needs more processing power, an MPU might be more suitable. If your device needs a sophisticated user interface, you will need hardware that can handle it. Qt for MCUs provides a great way to develop responsive and visually appealing UIs, even on resource-constrained devices. However, if your design requires more nicer graphics or touch interactions, an MPU might be more appropriate. Budget constraints often determine which hardware to choose. While MPU may offer more features, they can be costly and they can lead to longer development times. MCUs are generally cheaper, but might limit your options in terms of processing power and UI capabilities. You should evaluate the trade-offs between cost, performance, and time to market. Some hardware platforms come with certifications or pre-existing support for regulatory compliance. This saves you a lot of time and effort, especially when developing medical devices that need to pass like this regulatory regime. If you decide to go with an MCU, Qt for MCU is a specialized version of the Qt framework designed for microcontrollers. It brings a lightweight version of the popular Qt Quick framework. It is called Qt Quick Ultralight, and it enables the development of fluid and modern-looking UIs on devices with limited resources. This is particularly valuable when developing cost-sensitive, low-power devices without the need to sacrifice anything in terms of user experience, right? However, keep in mind that Qt for MCU is a commercial offering, so budget planning here is essential. Yeah, it's not needed for all MCUs and MPUs though. If you have a moment, I encourage you to visit the SciStudio website and our blog. Links are in the description. I'm pretty sure that you will find there something interesting for you. Also, please hit the like button and subscribe to our channel. This way you help us spread our message. Qt supports a wide variety of hardware targets, so you can develop software that can run across different platforms. Depending on your project, you may want to check Qt support levels, which are categorized as reference targets, verified targets, and other targets. Under those tiers, there are lists of devices, but actually the list of unofficially supported devices is way longer. I have seen people running Qt on cheap Chinese MCUs. Yeah, but as always, it is the safest to run Qt on devices that are officially stated as supported by Qt. Also, if you decide to pay for the license, there are plug-and-play Yocto images for many of those officially supported targets. So it makes your development faster. I'm not going to read all of the supported devices, but you can see that here there are both high-end microcomputers like NVIDIA Jetsons or Intel NUC, nice MPUs like IMX8, but also cheaper boards like STM32. Make sure to check the Qt supported embedded platforms page regularly, as new platforms are being added and updated all the time. Actually, a lot of people base their devices on the targets from tier 3. Let's now give you some example hardware choices to make this episode more tangible. I will show you a hypothetical project and explain my reasoning behind choosing target. Wearable pulse oximeter. For a small portable device like this, an MCU with real-time capabilities would be the best. You would choose an STM32 or NXP IMX-RT, for instance. And you would probably go with bare metal setup or free LTOS system. And you could develop the interface using Qt for MCU or something even more lightweight like LVGL. Portable ultrasound machine. For a more complex device requiring real-time image processing, an MPU would be more appropriate. Something like the NXP IMX8 series. It can handle multiple multimedia tasks and complex user interfaces. So this would work well. This could run a custom embedded Linux, and you would leverage full Qt for optimal performance. Patient monitoring station. If you are building a device that aggregates data from multiple sensors, provides some visualizations, and requires stable operation, a mid-range MPU running QNX might be perfect. Qt's cross-platform capabilities will ensure you can develop, deploy, and maintain the software across various hardware configurations. Okay, so now, after watching this episode, I think that you should know what are your options and how to approach choosing embedded target for medical devices. You have to consider the device's functionality, power needs, budget, development time, and MCUs are great for simple low-power applications, while MPUs are better for handling complex tasks, and they are better for rich GUI. Actually, Qt provides tools for both, you already know that. In the next episode, we will talk about the next important layer, which is operating system. Operating systems that are suitable for medical devices software. See you there.